concept of acceleration in physics is that it's a change in velocity over time. And maybe a simple way of summarizing that I've put over here in my whiteboard section is acceleration is equal to velocity divided by time. I've also written here on the key concepts page a couple formulas that describe that same idea. This first formula here is probably the most general vector version of this formula. The acceleration vector is equal to the change in the velocity vector divided by a change in time, or just time. It's probably okay to say that as well. This other version over here is probably more along the lines of what we're going to be using if you're talking about one-dimensional motion, maybe along some x-axis. So I put like a subscript x here. That's the kind of notation we're going to be using later in this course when we look at vectors a little bit more. So one can think of this as maybe a component of a vector or really just the amount of acceleration in the x direction. So the acceleration in the x direction is equal to the change of velocity in the x direction divided by time. Acceleration is pretty subtle. Acceleration in that sense is not speed over time or change in speed over time. So definitely, if something speeds up, it accelerates. If something slows down, it also accelerates. It's common in natural language to say it decelerates, but to a physicist, a deceleration is also an acceleration. It turns out, though, simply changing direction, like if a car goes through a curve, maintaining constant speed, it actually is also accelerating. And the reason why is because as it's going around that curve, the direction of its velocity is also changing, and that qualifies as an acceleration. That's something we're actually not going to be looking at so much in this chapter, but in future chapters we're going to be delving into that in some more detail.